Okay, so as we said earlier, we said that when you are analyzing and you want to calculate the refractive index, especially when the light is traveling from one medium to another. For example, now if we can use this example given here, we have medium 1 and then we have medium 2. If you are very keen, you will realize that the light, using the arrows, arrows are the ones showing the ray of light. Using the arrows, the light is traveling from medium 2 to medium 1. So meaning, if you want to calculate the refractive index of medium 2 with respect to medium 1, or medium 1 with respect to medium 2, then you need to be very attentive. And you need to check and know which one will you start with. For example, we have I at this particular point and we have R at this particular point. Let's say you want to calculate the refractive index of light traveling from medium 2 to medium 1 as shown by the arrows here. It will be very simple. It is going to be sine R over sine I. And if you want to get the vice versa now, you will have to take, if the light is traveling from medium 1 now to medium 2, it is going to be, the refractive index is going to be sine I over sine R. And also one thing that you need to know, I've done it for you here, but you will go and follow it. If you want to reverse the refractive index, that is after the light direction has been reversed, it's very simple. If the refractive index of medium 1 with respect to medium 2 is 0.5, then if I reverse the light, I will just do the reciprocal of the refractive index. That is, let's talk of this for example. The refractive index of light traveling from medium, medium 1 to medium 2 is the same as 1 over the refractive index of light traveling from medium 2 to medium 1. It's just but a reciprocal. That's it. A ray of light passes through air into a certain transparent material, which can be water, glass. If the angles of incidence and refraction are 60 and 35 respectively, calculate the refractive index of the material. Calculate the refractive index of the material. This one is one of the direct questions because you have been given I and you have been given R. So you simply key in your calculator. There is nothing to talk so much of that. It's just sine 60 over sine 35. That's a very direct question. That you don't have to brag that you have known physics. It's just a direct question. But it's good because you know it. It can be asked. Given that the refractive index of glass is 1.5, calculate the angle of incidence of a ray of light traveling from air to glass if the angle of refraction is 10. Please get this very clear from me this morning. By the time you are watching, it may not be morning. If we say the refractive index of glass is 1.5, automatically it is with respect to air. I may not write there with respect to air, but that's what you need to know. If you are told the refractive index of water is 3 over 4, or 0.75, 0.4, 0. Those, it is simply with respect to air. So if you're told it was traveling from air to glass, now the refractive index is 1.5, then that is it. Now the R is 10. So sine I over sine R should be equal to 1.5. Now complete those mathematics. Very simple, just this way. It's moving from air to glass. This is 10, this is I. So sine I over sine 10 should be equal to 1.5. If you don't know how to use a calculator and you know how to use a phone until you watch me in YouTube, hey, there is something wrong with you. The devils are joking with your destiny. Yes. Learn how you can't be perfect in using a font and a calculator. That is your destiny you are dancing with. Um, Look at this. Calculate the refractive index for light traveling from glass to air. Calculate the refractive index for light traveling from glass to air, given that when the light is traveling from air to glass, it is 1.572. Now, we want to calculate the reverse of light. It is simply the reciprocal of 1.572. This one, you have nothing even to use. Just use the calculator your parents bought for you to key in. Even the books you are using from your parents, the calculator you are using from your parents, the only thing you have is you and your brain. And it is also us who are teaching you to expand that brain. So 1 over 1.572, you will get your answer. Please, can you try these questions? Can you try these questions? You just pause the screen, you copy the questions, you calculate them, then you evaluate yourself. You always, by the way, you always know whether you have gotten it right or wrong. It's like the way right now you know whether you will go to heaven or not. You know, everybody knows. So it's like you now. So please, you cannot, after calculating a question, don't say who will mark for me. When you are taking your pen, calculator, and that book, at the end of answering a question, you always know whether you've gotten right or not. Kama umeandika Romans, then how do you expect it to get right? Another one is a very good question here. Just pause the screen, copy the questions, do it, then evaluate yourself. Another concept, I've already introduced to you one way of calculating the refractive index, that is using the Snell's law, sin I over sin R. Another one is by the use of velocity. That is, for you to get the refractive index, it is the velocity of light in medium 1 over the velocity of light in medium 2. A simple one. It doesn't have a lot of things. Now, for example, here, but the only thing I want you to know is this: how we can combine the two. That is the Snell's law and refractive index in terms of velocity. That's what I just wanted you to know. But being told to calculate the refractive index given the velocities of light in various medium is the greatest joke of studies. Now, look here. Let me just take you here. If you have this angle and you have this angle and you have a velocity of light in one of the medium, then you can get the velocity of light in the other medium. Now, that's a question that is making some sense. Look at this. Given that the refractive index of diamond is 2.51 and the velocity of light in air is 3.0 times 10 power 8, calculate the velocity of light in a diamond. Another joking question, because it is just the velocity of light in air over the velocity of light in diamond is equals to 2.51. Yes. Now, this is what I was talking about. It's making some sense, Kidogo. Given that the velocity of light in water is 2.27 times 10 power 8 meters per second, and in glass is 2.1 times 10 power 8, 2.1 times 10 power 8 meters per second, calculate the angle theta. Very simple. Now, we can get, first of all, the refractive index using the velocities of light. Water to glass. So, the velocity of water should be up. Then, the velocity of air in glass should be the denominator. So it is 2.27 times 10 power 8 over 2.1 times 10 power 8. You will get the refractive index of light traveling from from water to glass. The same refractive index of light is gotten by sine theta over the angle of refraction. Most of you will not calculate the angle of refraction. They will use 68. They will use 68. Please don't be that one. Don't use 68. 90 minus 68, you get the angle of refraction here, and you will be well to go. That's not a question to joke with, to spend time on. So those are the workings out. There's another one here. You have the refractive index of glass, and you have the refractive index of water. Now, where I want you to be very keen is this line, the one, the yellow mark, the pointer is running through. That line is not the normal. The normal is the dotted line, the one which is horizontal now here. Yes. So T60 is not the angle of incidence or what. It is just a 60. So calculate this particular angle here. You get 30. Then R is now the angle of refraction. Which formula do we apply here? Let me give you a formula that we apply in such a question, because you have been given the refractive index of water 4/3, of glass it is 3/2. Now it is this way. You take the refractive index of water times sine of incidence here should be equal to the refractive index of glass times sine r. First of all, this part is 60. I mean is 90 minus 60, which is 30. And the refractive index of water is 4/3. 4/3 times sine, just 4/3 sine 30 should be equal to 3/2 sine r. Then from there you proceed using your calculator. Yes, just as simple as that. The formula is here. Yeah. Exercise is there again. Please copy it and work on it. Then you mark it for yourself. I've said this and I will still say it, that after working a question, you always know whether you have gotten it right or you have done rumors. And if these rumors, then you need to revisit the topic, the slides we've done before. Yeah, these two questions are still yours. Work on them. Be very keen. These two again, still yours. From just what we have been doing, I'm just posting for you questions. Please work on it. At least I've given you a hint on how they can be worked on. Then check in my next video, refraction through successive media. God bless you, and please don't forget to subscribe.